Namaste everyone. Welcome to CET NEET class Doppler Effect. We are in the 33rd problem. 32nd we have finished, correct? So let us move on to the 33rd problem. A source of sound and a listener are approaching each other with a speed of 40 meters per second. So both are approaching each other. The apparent frequency of the note produced by the source is 400 CPS, 400 Hz. So then the true frequencies, they are asking you true frequency, actual frequency. Actual frequency should be, cannot be greater than 400. And apparent is 400. Apparent is more when they are approaching each other. So true will be less. So either this should be the answer or this one should be the answer. Okay, we will study the situation. A source of sound and a listener. So we will take this as the listener. Observer 40 meters per second. Source of sound 40 meters per second. Correct? We will take this as source of sound. Sound moving like this. How much? 360. Yeah. What is the apparent frequency is 400. What is the true frequency? Yes. Nu is equal to apparent frequency original into V plus V naught, right? V naught is plus minus Vs, correct? Now nu apparent is given 400. What is the true one? This one 360 plus 400 40, 360 plus 40, 360 minus 40. 400 nu naught 400 by 320. 360 plus 40 is 400, 360 minus 40 is 320. Cut, this comes here, 320. Direct one. Yes. Problem number 34. Yeah. A train has just completed a U-curve in a track. It is not complicated. It is completed. Spelling mistake. Yeah. A train has just completed a U-curve like this. So let me draw my own diagram. This is the track. A train has just completed a U-curve in a track which is a semicircle. The engine is at the forward end. That means here is the engine and emitting the smoke like this, and this is the tail end, last compartment. Engine is at the forward end and the semicircular part of the track, while the last carriage at the rear end of the semicircular track. The driver blows a whistle of frequency 200 Hz. Yeah, there is a sound emitted with the 200 Hz. Okay, let us see which sound is heard, because different passengers at different positions will receive the sound in different directions. Now the direction of motion of the source is like this, correct? Source is moving like this. Then 200 Hz. Then velocity of the sound is 340 meters per second. Okay, that is okay. The apparent frequency as observed by a passenger in the middle of the train. Yes, here. Now his motion is like this, right? This is the motion of the observer, and motion of the source is like this. What is the apparent frequency? Their directions of motion are perpendicular. Get the component of this like this. V naught cos 90 is 0. So what is the apparent frequency? Original frequency itself. It is 200 Hz. Suppose it is asked to find out what is the apparent frequency as heard by the observer in the last compartment. He is moving like this, right? That means the source is approaching towards the observer, right? So they are in the line of action now. Then you have to see the situation. Source is like this and observer like this, and that means we can see this situation, observer and source is moving towards him. So, or you can take source is moving away from the observer. You can take it like this. Okay, observer like this, source moving away from the observer, or situation like this. Anyway, right? Source like this, observer like this. I have changed it, that's all. And from the source you are receiving the sound like this. This situation you have to apply. Now it is 200. Okay, because they are perpendicular. 35. An ambulance blowing a siren of frequency 700 Hz is traveling at a speed of 2 meters per second towards a vertical reflecting wall. Now we are coming to the same point. If the speed of sound is 352 meters per second, how many beats will the driver of the ambulance will hear? So ambulance is driven with the speed of an ambulance blowing a horn sign of frequency traveling towards a hill with a speed of velocity of the car, that means velocity of the source, and there is a hill, maybe the hospital in the hill, right? That's why he's moving towards that. And the sound will be moving forward and reflected back. So apparent frequency nu double dash is equal to nu naught into v plus velocity of the car, v minus velocity of the car. This is what we have derived already. Because he has to hear the reflected sound from the hill. Hill will receive certain frequency. That is reflected and received as different once again. That is this one. Nu double dash is equal to nu naught 700 v plus velocity of the car. Velocity of 352 plus 2, 352 minus 2, that is equal to 700 into 354 by 350, is it 2 times 708, 708 hertz. Now question is, how many beats he will hear, the driver of the ambulance? 780 hertz reflected sound from the hill, 700 hertz originally, simultaneously heard, 8 beats per second. Answer A. Okay. 36. When an engine comes towards a stationary listener, the apparent frequency of the whistle of an engine appears to be 1.25 times its real frequency. Analyze the situation. When an engine comes towards a stationary listener, engine, ours is car, because I have a cheap car which can be drawn very easily. An engine moves towards a stationary listener. The frequency of the whistle of the engine appears to be 1 point. The speed of the engine is, okay, sound travels like this. Speed of the engine is source. Vs is like this, sound is like this. Yeah. Apparent frequency, real frequency, v plus velocity of the observer, v minus velocity of the source, this is 0 because stationary listener. Now their argument is, the sentence is, frequency of the whistle of the engine appears to be 1.25 times the real frequency. Frequency of the engine appears to be 1.25 times the real frequency, equal to real frequency into velocity of the sound plus 0 by 330 minus velocity of the source, which is in the negative direction. That is what you have to find out. Engine. Nu naught gets cancelled. Multiply this. 1/4 of, or shall we bring this here? 330 minus Vs is equal to 330 by 1.25. We'll do it like this. 1.25, we'll bring it here. 5 2s are 5s are 5 6s are 6s are, right? Anything 0.25 can be written as 1/4. That is an advantage for us now. 1/4, that is equal to, or that implies 330 minus Vs is equal to 4 into 66, because 0.25 is 1/4. 4 comes to the numerator. 24, 26. V as 330 minus 264 is equal to V as 264 means 36 plus 30, 66, right? So Vs is equal to 66. Am I right? 66 means 66 means 70, 330. Yes. Option D. They have given apparent frequency in some way, right? In terms of relation. And we have some questions like percentage variation, right? Here, 37. The speed of sound in air is 330 meters per second. If the frequency of sound increases by 50%, the source should approach the stationary listener with a speed of, you see, it is in 50%. The apparent frequency should be 50% more, means how can you take it? 1.5, right? Or 150. If you take original frequency as 100, new frequency will be 150 units. The speed of sound in air is 330 meters per second. If the frequency of sound increases by 50%, then the source should approach the stationary listener. Listener at rest, source should approach the stationary listener. Sound travels like this, V. This is the velocity of the source. Yeah, apparent frequency, real frequency into V plus V naught divided by V minus Vs. This is what you have to find out. Source should approach the stationary listener with what speed? Vs. Sound is in negative x-axis, however, it is in the standard value also negative x-axis. This has come to negative x-axis, that is taken negative. This nu should be 50% more than nu naught, am I right? The apparent frequency increases by 50%. That means half of this you have to add to nu naught and give you this one, 1.5. V by V minus Vs, V minus velocity of the source. V is given, right? How much? 330. 330 minus Vs. Same type of problem. Last time it was something different. Right. Cancel. Same problem we have. No. So 330 minus Vs is equal to 330 divided by 1.5. Okay, 1.5 2 times 3, 2 times 3, 0. Correct? 3300 by 15, 220. Yes. 1.5, 2 times 3, 2 times 3, 0. So what is Vs? Vs is equal to, Vs here 330 minus 220, 110. 330 minus 220, 110, yes. That is the answer, A. Only the sentences are a little twisted. 38. The pitch of a sound coming from a source of sound at rest. Source of sound at rest. Pitch means frequency. The pitch of a sound coming from a stationary source. So I will write this as source, Vs. Source of sound at rest appears to be decreased by 5%. If the speed of sound is 380, speed of man is, yes, appears to be decreased by 5%, correct? Decreased means this person should move away, am I right? Otherwise, how could it be? If he is approaching, it should be increased by 5%. Now it is decreased by 5%. Source, of course, not moving, but sound from the source should move. However, even if the source is at rest, sound will travel in all directions. This is the sound which is heard by the listener. We are not worried about this sound, this sound, this sound, all, because they are not listening. They were not heard by the listener. So we are interested with only that sound which is heard by the listener. So listener is moving away with the velocity of V naught. This is in the direction of sound, negative x-axis, minus. Vs is 0. Okay, so nu is equal to nu naught into V, velocity of the sound, plus V naught minus V naught divided by V plus Vs plus 0. Away from the source, either this one or this one we have to select, because towards means it should be more than the apparent frequency. Decrease, sound at rest appears to be, source of sound at rest appears to be decreased by 5%. Speed of sound is so much, speed of man is, yes. Decreased by 5% means this is 0.95. Nu naught is equal to nu naught, right? This has to be taken as 95% of nu naught, or you take this as 100 nu naught and take this as 95 nu naught. Finished. When 100 comes here, it becomes 0.95 nu naught is equal to nu naught into V minus V naught divided by V minus V plus 0. 380 only. Okay. Nu naught gets cancelled. Multiply this by 0.95. 380 into 0.95 is equal to 380 minus V naught. How much this will be? We will multiply it. 0.95 into 380 or 380 into 0.95. I have to go for lower classes now. 0, 40, 4 in hand, 19. Then 9, 0, 72, 7 in hand, 25. Right? 9, 0, 72, 32, correct? 50, 40. 40. 11, 6, 3, and 2 places, 361. 361 is equal to 380 minus V naught. That implies 380, V naught is equal to, bring V naught here, 380 minus 61, 380 minus 361, 61, 970, 80, 19 away. This should be the answer. Yes. 38. 39. Frequency of a sound changes by 20% as a source passes a stationary observer. From the stationary observer, as the source moves away, as it passes, yes, as a source passes, yes, this should be understood very clearly. Frequency of a sound changes by 20%. This is a beautiful problem. You see, so many things are involved in this. Changes by 20% as it as the source passes a stationary observer. Now, do you treat this as 20% of this one? No. As a source passes a stationary observer, they mean like this. Here is the observer, and here is a train coming. As it passes the stationary observer, here it is apparent frequency is more, here the apparent frequency is less, and this lesser apparent frequency is 20% less than this frequency. That is what they are saying. They are not saying the apparent frequency is 20% lesser than the original frequency. They are comparing two apparent frequencies. When you are standing like this, as the train comes, you will feel that the frequency is more. Suppose it is 500 Hz is the frequency actual, and as it approaches, you hear it as 508 Hz. As long as it is in front of you, it is 508. As soon as it moves away, it may be 495. Those two are 20% different. That is what is said. You see the sentence, as a source passes a stationary observer, as it passes the stationary observer, we feel a 20% drop. You remember that graph? It was more and suddenly it is less. 20% less. That is what you have tried. So we will analyze it. It's not a tough problem, only tough, or only there may be some problems in understanding the sentence. Frequency of sound changes by 20% as a source passes a stationary observer. We will write the formula. Here is the observer at rest. Okay. Now the train comes towards the stationary observer. Then the velocity of the source is s. Sound moves like this. This is one situation. Now after passing, so this is before crossing. Okay. Before crossing. After crossing, here is the source moving away with the same velocity, but the sound, this is the sound received. Here this is the sound, here this is the sound. Situation changes, right? So we will write the formula for each case. Here, apparent frequency, I'll write nu dash. Nu dash is equal to nu naught into V plus velocity of the observer divided by V minus velocity of the source. Why? Minus, negative x-axis. This is before crossing. Okay. After crossing, after the stationary observer is crossed by the train or whatever it is, source. After crossing, the situation is the observer is at rest and the car will be here, car will be moving away with the same. Reverse it. So this sound should travel like this. Here it appears to be positive x-axis. Let us reverse the situation into our standard value, because anything which is in the direction of sound is taken negative. Opposite to the sound is taken positive, because sound is in the negative x-axis. Or we will reverse the situation. Observer is at rest and this should recede away, isn't it? Put it on the other side. That car should recede away, velocity of the source, sound should come like this. That means this is positive now. Apparent frequency, real frequency V plus velocity of the observer, V plus Vs. It has come opposite to the direction of the sound. So sound opposite, right? So plus, retained. Because in our standard situation, sound is only in negative x-axis. But both the observer and source were in positive x-axis. So they were opposite to the sound. Okay, this is the situation. They say that, see, this should be lesser, denominator greater. This one is answer should be more, denominator lesser, minus Vs. So answer should be more, answer should be less, denominator is more. And this is 20% drop. It changes by 20%. This is 20% drop than this. So shall I write it now? Nu dash, nu double dash should be 0.8 of nu dash. This is more, it's 80%, 20% drop is nu double dash. Only 80% of this is this one. The apparent frequency as it crosses changes by 20%. Change means as it moves away, it is less. As it is approaching, it should be more. So 20% less when it moves away. Nu double dash is 20% less means 80% of nu dash. Now write the two equations. Nu naught into V by V plus Vs is equal to 0.8 of nu naught, this one, V by V minus Vs, V by V minus Vs. Nu naught V gets cancelled. Now what do you get? I will bring this V minus Vs here. V minus Vs equal to this one, 0.8 V plus 0.8 Vs. 0.8 V plus 0.8 Vs, okay? V minus Vs. What else we can do? I can bring this 0.8 here, V there. Oh, you get negative. No, minus Vs here, minus Vs and plus Vs here. This one here. So V minus 0.8 V. Where should I write? Shall I write it here? V minus 0.8 V is equal to, this has come here, this one positive. 1.8 Vs. I'll directly write it. What is velocity of sound is given? 360. Yeah. This is 1.2 V, 1.8 Vs. What is Vs? 0.2 V by Vs is equal to 1.8. We want Vs. 0.2 V by 1.8 is equal to Vs. What is 0.2 V 360 by 1.8 is equal to Vs 9 times 40 times. Very beautiful problem. Only the thing is not in mathematics and solution, understanding this sentence. As it passes there is a drop. It is not with the original frequency, it is with the two conditions, 20%. Okay, so 40 meter per second, option D. Two factories are sounding their siren at 800 hertz f. Okay, a man goes from one factory to another at a speed of 2 meters per second. Okay, the velocity of sound is 320 meters per second. Number of beats heard by the person in 1 second will be. Then beats heard per second means beat frequency. There are two factories, A and B. Say A, factory A, factory B. Both are producing sound at 800 hertz. 800 hertz. Two factories are sounding their sirens at 800 hertz. A man goes from a factory to another at a speed of 2 meters per second. Observer I will take. Factory A to factory B. Another at a speed of 2 meters. The velocity of sound is 320 meters per second. Okay, that we will take later. Then the number of beats heard by the person in 1 second will be. Why should he hear beats? What is the reason for hearing beats? He will never hear this as 800, this as 800. He is receding away from this 800. It appears to be lesser, say 795. And he is approaching this 800. Appears to be more, say 805. 795 and 805 heard simultaneously. So 10 beats per second. That's what you have to do that. But that is a simple number I have told. That may not be the answer. Now, from A, we will see. A is emitting sound waves of 800 Hz. So, velocity of the source is 0, right? And it is emitting sound like this, and the observer is moving away from that sound with the 2 meters per second. Now what has happened is, now I don't write the standard situation, I will leave it here. In the direction of sound, the observer is moving. That means, the source is moving, right? Source is at rest. Here source is at rest. Observer is moving in the direction of sound. That means V0 should be negative. You take the reverse case. Here is the factory and here I am. I am moving away from the factory, right? Away from the factory like this. Sound is coming towards me. So it is in the direction of sound. So it is negative x-axis. So sound should be always as it is in the formula. So nu dash is equal to nu naught into V minus V0, because it is in the same direction as sound, divided by V plus Vs, 0. So what is nu dash is equal to nu naught 800 into velocity of sound 320 minus observer 2 meter per second, right? Here I have written minus 2 divided by 320, correct? 320 minus 2 by 320. This should be heard less, isn't it? He is moving away, so it should be heard less, because you see denominator, numerator less, denominator more, V minus, simple V. So 800 into 322 by 320. 84s are 85s are correct. 80, right? 84s are 80 tens are. What will be the answer then? Then this will be 800. Yes, it will be heard as this is 80.5, so 805 Hertz. This is one situation, 805 Hertz. Now imagine this factory B. He is approaching towards factory B. Now the source of sound is at rest, factory B, and the person is approaching towards this factory. So observer is moving with the 2 meters per second and sound is coming like this from the source. Apparent frequency, nu double dash, original frequency into V, velocity of sound, plus V0, because V0 is in positive x-axis, sound is in negative x-axis, divided by V minus 0 or V plus 0, because observer is at rest, V minus V, source is at rest. Nu double dash is equal to nu naught into V plus V0 divided by V plus 0. Am I right? V plus V0 divided by source, no velocity. So that implies nu double dash is equal to nu naught 800 into 320 plus V0 plus 2 divided by 320. Here minus 2, there plus 2, that's all. 80 tens are 84s are. That is 322. Nu double dash is equal to 322 into 10 by 4. Oh, here it has gone wrong. How can it be 322? I am getting the same answer. So this is 405, correct? That is 805. This is 805, correct? 805 Hertz. I am getting very good calculation answers. This is not 805. This should be less, right? It should not be more. So this, how can be 320 minus 2 is 322. This is 318. 318. And okay, I will do that again. 800 into 318 divided by 320. I am surprised. I got 805 in both. So here it should be more. Here it should be less. Okay, 84s are 80 tens are 4 7s are 3 in hand, 9s are 0.5, right? 795. Oh, I was talking the same numbers, right? So 4 7s are 3 in hand, 9 is 36.5, 795 and 805. So it is 10 bits, yes. Same answer I got. I was randomly saying some numbers. Okay, so now you will have to move on to, yeah, it is stationary waves. So we will consider the stationary waves in the next video. I'll come back in the next video. Thank you for watching.